and welcome to this session. It's the first one I've done, and it's the first time I've used Zoom, so fingers crossed everything goes okay. Probably a little bit about myself. First of all, I'm the principal examiner for the lower secondary science course. I started teaching in about 1985. For many years, I was head of the science faculty in a large school in Northern England. But I've also worked abroad. I worked in Spain for 6 years. So that was really valuable experience because I got used to teaching science to students who were learning in what was often their second or third language. So very relevant to the course that I'm principal for. I've been working for Pearson as an examiner for about 15 years, and I work on several different papers, including the IGCSE papers, which follow on for this, so that it's good that I know what this paper is leading into for many of the students who take the paper. And I've been the principal on this paper since the specification was changed in 2018, 2019, and I've written, I think, every paper since then. So what this webinar is aiming to do are the things I'm showing on the screen now. I'll start with a description of how the paper is produced. I think that's quite useful to know why the paper is as it is, and all of the constraints that are in place, and the things we do to try and make sure the paper is fair and valid for the students taking it. I'll then talk about how the paper is marked, and I think there's some useful things in there that you can pass on to students, which might help them with exam technique and things like that. I'll talk about a little bit on how we set the grade boundaries, and then I'll try to talk a bit about the principal examiner's report, which I produce at the end of every exam session, and try and push that and encourage people to read that. And part of that will be trying to give a little bit of advice on some things that pop up that might be useful to know, that will help you to prepare your students for the exams. That should take, I'm hoping, about 30, at most 40 minutes, and then we'll have some time for questions and answers. I'm happy to try to answer any questions you might have. If you have questions while I'm talking, if you want to type them into chat, I'll try, if I can, to keep an eye on that and answer them as we go along. I'm happy to do that. So first of all, talk about the writing process. And the aim is to produce a paper that's based as closely as we can on the specification. There shouldn't be any big surprises in there. We work very hard to make sure and double check that everything is covered. Everything in the paper is covered in the specification. That's not to say we can't set things in different contexts, and that's often what we do. One of our main aims is to make sure the paper is consistent in its format and similar to previous series. So there shouldn't be any surprises. You should see each series, the paper is very, very similar. And very important is that it's consistent in standard with previous series. We work very hard to do that. The constraint that I work towards when I'm writing the paper, try to ensure that happens. But any slight differences we deal with once we've got marked papers, and we're rewarding and setting grade boundaries. We want to be fair and make sure the paper is accessible to all students. We're very aware of language we use and so on. The first step is I receive a contract to write a paper, and I sit down, and it takes me quite a long time because it's quite a complicated paper to write. As you know, we've got 80 marks, 60 marks in section A, which is based on the biology, chemistry, and physics content, and then 20 marks for section B, which are covering scientific inquiry. So first of all, I've got to hit that and make sure I've got the right number of marks in each section. But then there are lots of drivers that I need to ensure I meet as well. For example, as you know, when we grade, the students are graded S1, S2, S3, or S4, and I have to make sure there are the right number of marks available at each of those different attainment levels. As well as that, I've got a target that a certain number of questions have to be accessible with a low cognitive demand and a certain number with a medium cognitive demand. Then of course we've got the 4 attainment targets. They are 1, 2, 3, and 4. So roughly they are based around knowing something, understanding something, applying something, and drawing conclusions and so on. Evaluating. Each subject area is an equal number of marks. And then we have different question types, and I've got to fit in a certain number of maths marks as well. So all of those drivers, it's a little bit like those tile games. That's why I put the picture there. You change one thing and it has an effect on everything else. And very often we're shuffling things around and trying to rewrite questions to fit that, all of those drivers all at the same time. And that's what takes the time in doing this. The writing process is quite long and involved. There are about 8 steps. You can see, first of all, I'll sit down and I'll produce a first draft. And that's guided by all of those drivers I've just talked about. There's a spreadsheet which we call an AOD, which is designed to help me keep track of those and make sure we get the right number of marks in each section. Once I've produced that first draft, I'll send it into Pearson, and it's sent out to a scrutineer and to the chair of examiners and the reviser as well. And they will sit down, they will go through that paper with a fine-tooth comb, and they'll really look for anything at all that they can find that they would feel could be better or could be better changed. So I receive that feedback, and then I will rewrite the paper in the light of the feedback I receive. At that point, I send it back into Pearson, and the paper then goes before a committee called QPEC, where yet again the paper is literally pulled apart. Every question, every word is poured over, and a lot of the time questions are rewritten, language is checked. And at that point, once we've gone through that, it takes 2 days with a committee of about 4 people, including the chair of examiners. The paper will be sent to the typesetter. Once the paper is typeset, it's again sent out to different people to check it, proofreaders, another scrutineer, sometimes an additional check. And each of those people will send feedback, which I have to respond to, maybe adjust the paper or argue my case for not changing it. And we might go through that loop 3 or 4 times until we're all happy with the paper that's there. At that point, we produce a second proof, and yet again, it's checked and amended as needed before it's sent off to be printed and ready for the exam session. At that point, we also begin to set up a system called ePen. ePen is an online system where we mark the papers. Once the paper's been sat, they're scanned into the system called ePen, and that's where they're marked. So papers are marked online. I don't know how aware candidates are of that, but it's probably a good idea to let them know. Because the papers are scanned in, what that means is if they write in a red pen or a green pen, or they highlight things, then that's not going to show up on the scan especially well sometimes. So I would always advise that students write in blue ink or black ink or pencil for graphs. So the paper is sat by students, it gets scanned into the ePen system, and at that point, the marking team will start work. So I will have a team of markers, usually with a team leader or 2 who has markers working for them. And the first thing they do, once the papers become available in ePen, is to start what we call familiarization marking. What I ask my markers to do is to mark about 15 responses for every question. Those marks don't count. Everything will be remarked. This is just markers getting familiar with the paper, with the mark scheme, and with the way in which students are responding to the questions. After familiarization marking, any marks that have gone into the system are wiped out and then will be remarked again. But during familiarization marking, the markers, they will report back to me, telling me how well particular questions are performing, if students are answering them in the way we intended, or if they found another way of answering it that we hadn't thought of. And all of that feedback is very, very useful, because I use it then to rewrite the mark scheme. It won't be a full rewrite, but we will amend it, and we'll take into account all of that feedback that we get back in from markers. So we end up with a final mark scheme. And at that point, I ask markers to destroy the draft mark scheme they've been using, and only then use the final mark scheme. Part of what we also do is set up the online system to set up what we call standardization. All of the markers have to pass a standardization test to show us that they understand the mark scheme and can apply it in the way that we intend. And in that way, we ensure that standards are consistent across the paper. So we call it OLS. Once we've gone through the mark scheme and everything like that, the system is set up, and the first thing markers have to do is they mark 10 qualification items for every question. The senior marking team, myself and the team leaders, will have already marked those standardization questions, and markers are expected to get the same mark as we have given it. They see 10 for every question, and the pass mark for them is 8 out of 10. So we'll allow them 1 or 2 little mistakes, but we will give them feedback, and that way we ensure everybody is marking to the same standard. Once a marker is through the standardizing process, they can begin live marking. They can start marking the allocation they've been given. Have I got a question here? I'm just checking. Right, someone is asking me, is it mandatory to write in black pen since the instruction is given to use black pen? It's good advice to use a black pen, but blue ink would work just as well, as long as it stands out when it's being scanned. So black or blue is fine, but I would avoid red or green or anything like that. Reply to that. Okay. So during live marking, what happens is that a marker will work on one response at a time. So in that way, they get a good chance to get the mark scheme firmly in their head, and hopefully we achieve some consistency. We always try to mark positively and give candidates, give students the best chance to show us what they know. So if there's any way at all that we can give a mark, even if the mark is given with poor spelling or something like that, as long as we can read it and understand it, then we will give marks. I've got a couple of little examples here. This is a question where a student has given quite a nice response. They've been asked basically to describe the lime water test for CO2, and they've described it reasonably well. They've got used lime water was turned cloudy or milky, so that would be worth 2 marks, but they've crossed it out. In that case, we would still give the 2 marks, even though the student has crossed it out. If they haven't given an alternative response, we would give the mark anyway. If they cross it out and write something else, it's the something else they write, the follow-on work, that would be marked and get the marks. Another example. Explain why the structure of arteries and veins are different is the question. And this student has talked about arteries have high pressure, veins have low pressure, so that's definitely 1 mark. But they've gone on to talk about lumen. Now, lumen isn't mentioned in the specification. So it probably wouldn't be mentioned in the mark scheme. Having said that, I instruct my markers if something unusual like that comes up, if they recognize that it's of the standard we want, it's credit worthy, they can give the mark, or they can refer it to their team leader or myself. We will make a decision on whether we will count that or not. So we try our very, very best to mark as positively as we can and give credit where credit's due. Have I got another question? Just a second. No, that's okay. Thank you. So we mark positively. During marking, all of the markers are continuously monitored. And we do that in 2 ways. First of all, about 1 in 10, 1 in 12 of every response they mark will have already been marked by the senior examining team, and we expect markers to come up with the same score that we gave it. If it doesn't, we can spot it in ePen, and we can then talk to the examiner and get them back on track with marking to the standard we want. Similarly, the markers have a team leader, and the team leader is sampling the marking. They'll sample the markers marking about 2 or 3 times during the marking period. And again, if it's not at the standard we want, we work with them to try and get them on track. If we find, having done that they're not marking accurately or as accurately as we would like, then they will be stopped from marking on that item. So we work very hard to make sure things are marked to standard and consistently. So it usually takes 2 to 3 weeks for all of the papers to be marked. And at the end of the period, every marker is expected to send me a report. And in that report, they will give me feedback on how things went, on questions that were answered well, questions that were difficult for students, common misconceptions, and so on and so on. And that feedback is very, very valuable, because that's the information that I will use when we go to the awarding meeting and set grade boundaries, and also it's the information I use to produce the examiner report, which is published online. So once all of those are in and I've looked at it and considered it, we move towards an awarding meeting. The awarding meeting is held with a committee of about four people, including the chair, myself, and some other markers. And how we decide on the grade boundaries is by looking very carefully at the paper and comparing it to a previous series. And we will look at scripts from both series, either side of the expected grade boundary. And we will compare this series with the previous series and make a decision on whether the demands of the current series are the same or very similar to the previous series, or we feel it's maybe more difficult by a mark or two, or easier by a mark or two. And based on that, then we will set the grade boundaries. So the grade boundaries will go up or down a few marks each time, according to how the paper has performed. So we've already worked very hard to try and make sure the paper has a similar standard each time. Any slight variation is accounted for in that way. After awarding, I finalize my report, again, based on all of that information, and that goes online. I also get a lot of statistics, including things like the mean and mode mark, standard deviation for every question. All of that helps me produce that report as well. My aim in that report is to point out questions and topics that have been answered well, students cope well with, and areas where there are obvious weaknesses across the cohort, which might help you to sort of focus your teaching for the next series. The report always follows a similar sort of format. It will start with a sort of fairly general introduction, and then I go through question by question, almost every question, talking about how they've performed. And then there's a final summary. And I think the final summary is probably the bit that's most useful, because it's in there that I'll pinpoint things that are regularly coming up, that there might be a, if you read between the lines, there might be quite a bit of a clue that I was concerned that this wasn't answered well, so maybe that might come up in the next series and so on. The final summary, I think, is very useful. I'm now coming to the section where I'm thinking about practically some observations that I've made that maybe will help you with your teaching of and preparing students for future exams. A lot of this might be fairly obvious, but I think it's worth saying. On average, usually, almost every time, section A is answered better than section B. The obvious answer is section B is worth 20 marks. It's worth perhaps spending a little bit of time, or giving it a little bit more emphasis, and trying to improve students in that area. It's a good chance to let your candidate shine and sort of gain some extra marks. I think students naturally will focus on content, knowledge and understanding of the items in the specification. The skills that are tested in section B, it's harder for them, so it's worth, as a teacher, spending a little bit of extra time and focusing on that. Not surprisingly, multiple choice and prose type questions are usually done well, better than open response questions. So again, it's worth spending time practicing open response questions. Bit of an examiner's plea here. Poor handwriting always makes life difficult. We will always try our best to read and understand what's being written, but sometimes with the best will in the world, you just can't read it. So it's not easy in cases like that to mark or to give any marks. Sometimes an examiner will send me a response with the message, "Help, I can't read this." And I think they expect me to put my magic glasses on and read it for them, but I can't. It's, I find it just as difficult as anyone else to read poor handwriting. So if we can encourage students to do their best. One of the main things is a lot of students nowadays write very, very small. Their writing is tiny. And then when it's scanned in and we're looking at it on a screen, it's very difficult to read. Even when we will do our best, we'll enlarge it and so on. But any help there would be really appreciated. Core math skills often cost student marks. We have up to about 15 marks per paper, which are based on maths. There will always be a question which requires students to rearrange an equation. Might be the Ohm's law equation or something like that. And that's a skill which they aren't great at. And that's often where they will lose a mark. If they can't rearrange an equation, it makes it very difficult for them then to score in that case. And the other big one is the 2 and 3 mark questions. We'll usually have the command word describe or explain. They're often answered poorly. The majority of students, if they score, will score 1 mark, but will rarely go on to score full marks. It's only the very best students usually score 2 or 3 marks on these questions. I'll talk a little bit more about that in a minute. And finally there, just general observations, is poor exam technique costs marks as well. And I'm going to talk a little bit about that now. So with exam technique, there are some common mistakes we come across time after time. So here's a typical response. Student is telling me arteries carry oxygenated blood and they carry blood away from the heart, while veins carry deoxygenated blood and carry blood towards the heart. So the science is good. There's nothing at all wrong with that. There were 2 marks available in this question. But the question was, explain why the structure of arteries and veins are different. So even though that answer has good science, it doesn't answer that question. They've not seen or noticed or taken note of the word structure. So their response doesn't answer the question. So in this case, that would get 0 marks. So it's fairly obvious that students need to answer the question that's actually asked, so they need to read that. Every question will have a key command word, and they need to get used to looking for those command words and responding in the right way. In this case, the command word was explain, and then they need to read on. This is a second example there. Another common mistake. The question this time is, what's the main function of veins? Different paper, but similar question. It will transfer blood. And again, you might say, well, that's okay. Surely that's worth 1 mark. But we look at the stem of the question. And the stem actually tells them blood is transported around the body by arteries, capillaries, and veins. So I've told them that. They've basically told me what I've already told them. I can't give them credit for that. So the message here, and it happens all the time, is please ask students not to repeat the question. Even if this student went on, students often start by just repeating the question, and at best it's a waste of time. At worst, they're not going to score anything because of that. Another one, the message this time is, again, read the question, look for the key words, look for the command. So we're told draw 1 straight line. This student has drawn multiple lines from the bacteria box. It's kind of like they're hedging their bets. I'm not sure of the answer. I know it's one of these, so I'm going to get the mark, but I'm sorry, no, there would be no mark in that case because I would have to make a decision on which one they're meaning. So again, the message is read the instructions, follow the instructions. Another example, same question. What's the main function of veins? They carry blood towards the heart, and they carry deoxygenated blood. Whoops. Let's just go back there. This was a 1 mark question. They give me 2 answers in a way. They carry blood towards the heart and carry deoxygenated blood. They're lucky in this case that they would get the mark because they're both correct. But in a situation like this question was about projecting a ball bearing and measuring the range. And I asked them what's the dependent variable. And this student has said the range, which is correct, and the angle of projection, which was not correct. So again, I've got to make a choice here. Sometimes it's worse. Sometimes students will give me a big long list of things in the hope that I'll pick out the right one and give them the mark. I can't give marks for lists. If they were both right, they would get the mark. In this case, we had 1 right and 1 wrong answer. So that would score 0. So the message there is ask students to avoid lists. If it asks for the 1 item, just give 1 item, make a decision and go for it. Very often they shoot themselves in the foot. They give more than 1 answer and they shoot themselves in the foot. Another common type of question is where, well, first of all, it's an explain question, which will usually have 2 or 3 marks. And I'm asking them to do a comparison, explain why the structures of arteries and veins are different. Now, this students try to focus on pressure, but they've used the word they here because they are under a very high pressure. We'll read that as. But I'm asking myself, what do they mean? Do they mean veins or arteries? They doesn't really mean anything. So it's the it and they thing. Make sure their sentences have meaning. And if it's a comparison, really, ideally, I'd like to see a comparison. So one has high pressure, one has low pressure, and tell me which. That would be a much better answer, much more likely to score the 2 marks. This would score 0. I don't know what the they means. Explain questions are usually worth 2 marks, and most students at best score the first marking point. The first marking point is for identifying some relevant point. The second marking point is for a linked justification or a reason. So I have an example here. Explain why the structure of arteries and veins are different. And the student has told me arteries have thick walls and a large lumen, while veins have thin walls and a small lumen. So walls and thin walls and the lumen is going to get them the first mark. They've identified something that's different about the two. So they've got the first mark. What they haven't gone on to do is explain why that's important. So they've gone on to say, because arteries are under higher pressure than veins or something like that. So they've taken it further, they've developed their point, and they've explained it. So when I was teaching, I always encouraged the use of the word because, or the term this is because, or this happens because, or even so that, something like that. There should be 2 items separated by something like that. If we see one of those things, it's usually a good sign that the student knows what they're doing and they're answering the question well. I look a little bit more at section A, and a few suggestions. Probably these are all old hat and sort of you're very aware of them, but it doesn't mean I shouldn't say them. Generally, students are better with multiple choice and closed questions than SOR. So the obvious answer is practice SOR questions as you can, particularly those that are describe and explain. Time after time, I'm finding students are not great at understanding the particle model and diagrams showing particles. For example, on talking about change of state, the diagram for a liquid is often very, very confused. My view is in a liquid particle should be touching. They often show them more like a gas with particles all over the place with big gaps between them. The difference between atoms, elements, and compounds, they will often use particle diagrams there in a question. That's often not well understood. So sometime developing those ideas would be good as well. As you might expect, lots of students struggle with chemical equations, balancing equations, naming salts, all of those things. So again, it's all good practice if you can devote time to that. It's disappointing when I consider a basic easy question, just simple knowledge straight from the specification, students don't know it. So they need to know the basic terms and vocabulary, including units that are within the specification. Nice if they come back in those words. They don't always, but we do our best. But very often students leave those blank and they're losing easy marks. Good advice would be to practice calculations. There are always a couple on the paper. Rearranging equations is a skill which is important there. In section B, as I've said, generally section B isn't answered as well as section A. Even though from one series to the next, the questions are basically very, very similar. The thing that changes in section B is the context of the question. So there will always be questions where they're expected to identify variables. There'll always be some sort of data to analyze in a table or draw a graph, describe a relationship. There will always be very, very similar questions. It's just the context that changes. Best answers to questions in this section use that context rather than giving generic answers. So they will read the question, they'll make sense of what's going on, and they'll use the context there rather than just trying to churn something out that they've learned generically. With variables, students are usually fairly confident with independent and dependent variables. They're less confident with control variables. So making sure things are fair and valid, and giving reasons why it would be good practice, good thing to learn. And section B is worth 20 marks. As I've said, a lot of students are losing marks in that section. So any time you can spend developing their skills in that area will be time well spent. Graphs, bit of a mixed bag with graphs. We get some very, very nice, accurate, well-drawn graphs, and then other times we get an absolute mess to try and unpick. I'll try and talk a little bit more about what I'm looking for there in a second. One area that comes up time and time again, I will often ask the question, how could I describe the method? And the question here is, how could the student make sure the results are more reliable? And that's the answer I get time after time. Repeating and repeating it, repeat the measurements. And my view is, just by repeating experiments doesn't necessarily make them more reliable. I'd much prefer an answer like this one. Well, yes, you repeat it, but then what are you going to do with the repeats? And I'd like to see students telling me they will take an average, they'll use the average of the results, or I didn't go to the previous screen. There it is. Or compare repeated results, something like that. But just repeating on its own, often we won't give the mark for that. We would much rather see repeat and average, or repeat and compare, something like that for reliability. So let's talk about graphs. Lots of nice ones. Where are the marks given? There are marks given often for putting numbers on a scale. And we'd like to see a nice linear scale. They're going up evenly. We'd like to see them using at least half of the grid, the plotted point giving half of the grid. And sometimes they need to label. Well, the axis will always need a label. If I ask them to label it, make sure they include units as well. And avoid difficult scales. For some reason or other, some will go up in 3s and things like that, and then it makes their life very difficult to plot their points. That makes our life very difficult if we've got to check them as well. So avoid difficult scales, and try and use nice 2s and 5s and 10s and so on. Plotted points, we like to see them within plus or minus half a small square. And just a practical point, as I've said, the papers are scanned in. Some of them will tend to put like a small dot or a point, and very often it's difficult to spot those on the scan. So I'd much prefer if they use a cross of one form or another to mark their points, not blobs, not big blobs, because that isn't accurate and we will often deduct a mark for that. Line of best fit should be a straight line or a smooth curve. Usually at this age, the line will pass through all of the points I put on there, unless there's a deliberate anomaly. We don't like to see tram lines or sort of artists sort of type sketches and so on. So a nice smooth line, no double lines, no tram lines and so on. And not dot. A lot of them treat it like a dot puzzle, and they will include the anomaly as well. So avoid the anomaly, don't include that, and try to smooth out a curve if it's curved. Don't just go dot to dot. So it's all common sense, it's all stuff you all teach anyway, but they're the things we see coming up time after time. Often I'll ask students to describe a relationship. And there'll often be 2 marks on this, and most students don't get the second mark, get the first mark. For example, in this top graph here, they might tell me as the voltage gets bigger, the current gets bigger also. So that would be 1 mark. The second mark is usually for them telling me a little bit more. In this case, they could tell me it's a linear graph, it's a straight line, or the current is proportional to the voltage, something like that. But they've told me a little bit more. So in my opinion, graphs tell stories. I want them to tell me the story of the graph. So 1 mark for an type statement. The bigger the voltage, the bigger the current. And then a second mark, they've described something to do with the shape or the gradient or the pattern. This mark is easy. Most of them get that. Far fewer get the second mark, so it's worth encouraging that. If the graph's more complicated, there's no harm in splitting it into sections and telling us what's happening in each section. So in this case, they could say the velocity increases with time if the bottom axis was time, but then for the second mark, I'd like them to talk about a decreasing gradient or something like that, or even if they said it's not a straight line, it's a curve, they're showing me they recognize that something about that graph and about that relationship. Right, I think I've spoken for about 40, 45 minutes now, so now I'm open to questions.